provided by Thomas Allgaier and Freenis, based on the most relevant LinkedIn posts about charging and battery technology in calendar weeks 32 and 33. Freenis is a B2B market research company that supports automotive suppliers with building feature-by-feature competitive intelligence that shows exactly how their product stacks up against the competition. You can find more info in the description. So imagine a nationwide power plant that costs the government $0 to build. It's entirely decentralized and, spends like 95% of its time sitting completely idle in our driveways.
Right.
Today, we're looking at how the mobility transition is shifting. We're moving out of this kind of chaotic, experimental hardware build-out and entering a really ruthless optimization game.
Yeah.
It's no longer about just planting a flag on a map. I mean, it's about utilization, margins, and the actual underlying physics of how we move energy.
Yeah, the mindset across the industry has just fundamentally fractured. I mean, operators are realizing they have to manage grid interconnects exactly like utility companies do. And simultaneously, we're seeing heavy trucking scale up to these unprecedented power demands.
Oh, absolutely.
And electric vehicles themselves are rapidly transforming from just being energy consumers into mobile power plants that actively support the broader grid. So we're going to explore these top trends to see exactly how this is playing out.
So to really understand that shift, we have to pull back the curtain on the hidden economics of the hardware. And counterintuitively, that means looking at the power that is not being used.
Yeah, the stranded capacity. It's like the biggest secret in the industry right now. Michael Greenberg recently analyzed EVgo's quarterly earnings, and the numbers are just staggering.
Okay, how so?
Well, EVgo has roughly 600 megawatts of connected utility capacity across their network.
Right.
But management noted that about 35% of that capacity is currently sitting unused based on their daily usage patterns.
Wait, 45%?
Yeah, 45%. That is nearly 270 megawatts of energized, secured urban grid connection that is just sitting idle.
Wow. I look at that 270 megawatts and I just think of owning prime digital real estate. I mean, you've already endured the multi-year permitting nightmare, right? You've paid for the trenching, the transformers, the actual location.
Oh, yeah, all our stuff.
Exactly. So if you own an interconnect with that much excess juice in a dense urban area, purely selling vehicle charging just feels like a missed opportunity.
It really does.
You could rent out that connection for edge AI compute, processing data locally for nearby autonomous fleets. Or drop in battery storage and play the arbitrage market buying power at night and selling it back at noon.
But yeah, it shifts the core business model completely. The interconnect itself becomes a monetizable asset, entirely separate from the charging dispenser.
Right.
So the operator who controls urban grid capacity is sitting on one of the scarcest resources in the modern energy economy. They're basically pivoting from being a charging network to being a distributed energy resource network.
But securing those grid connections at maximum scale is prohibitively expensive, which is why we're seeing operators engineer these clever ways to cheat the math. Brandon Flash recently broke down the engineering at the new Tesla Diner site.
Oh, yeah, the massive one.
Right. And this location runs roughly 20 sessions per stall per day, which is like 4 to 5 times the utilization of a typical fast charging site.
That's huge.
It is.
Yeah.
And across 80 stalls, the site has a theoretical max output, a nameplate capacity of 26 megawatts.
But the brilliance of the site design is that it doesn't actually draw anywhere near 26 megawatts of continuous utility capacity.
Precisely. They're relying on real-world arrival patterns and these power routing cabinets because, when a vehicle plugs in at, say, a 10% state of charge, it pulls maximum amperage.
Right.
But as it fills up past 70%, the battery chemistry basically demands a slower charge rate.
Right.
So the power cabinets dynamically detect this, and they shift that excess amperage to a newly arrived vehicle next to it.
Yeah, that power sharing is key. It means you can deliver an ultra-fast experience to 80 cars simultaneously without paying the utility for a dedicated 26-megawatt grid connection.
Which would be astronomical.
Exactly. And avoiding those utility costs is literally a matter of life and death for these sites. High utilization hubs can leverage that power sharing to keep their operating costs in check per session. But low utilization sites, they're getting absolutely crushed by archaic utility tariffs.
Right.
Steve Burkett highlighted a really painful example of this in Gorham, New Hampshire. A small business owner opened a 4-stall supercharger site to basically serve an EV charging desert.
So that entrepreneur is effectively providing a public service, and they're just being penalized for it.
Devastatingly penalized. The site is facing $9,000 a month in utility demand charges, regardless of how many cars actually plug in.
Oh my gosh, $9,000.
Yeah, because commercial electricity isn't just billed on the total volume of energy you use. It includes a demand charge based on the peak power drawn during a specific window, usually like 15 minutes.
Right.
So even if only 2 cars charge all month, if they happen to plug in at the exact same time and pull high power for 15 minutes, the utility sets the monthly rate based on that massive spike. I mean, It threatens the survival of the site entirely.
See, that structure essentially guarantees that independent operators in emerging markets will fail because demand charges make high utilization a matter of financial survival. And you can see exactly why retail behemoths have this massive structural advantage here.
Oh, absolutely.
Shiri Levi-Lohr pointed out that Walmart's current EV charging expansion isn't really about them trying to become a standalone energy provider.
No, they're playing an entirely different margin game.
Right. I mean, they already own the real estate and they already have these vast grid connections for their supercenters. So for them, deploying chargers is literally just a customer acquisition strategy.
Yeah.
If they lose money on the demand charge, it doesn't even matter because the real goal is just keeping a driver on the property for 30 minutes.
Exactly. The charging margin is totally irrelevant compared to capturing the revenue of a cart full of groceries or, an overpriced coffee.
Yeah.
And because demand charges require high utilization to survive, operators can't just plant a charger in a dark corner of a parking lot and walk away anymore. They have to actively lure drivers in, which completely changes the nature of the product they're selling.
Joshua Copeland crystallized this beautifully. He argues that the EV charger isn't the product anymore. The site is the product.
That is a crucial distinction. The hardware is just the baseline expectation now. I mean, drivers don't evaluate a charging session based solely on the voltage. They evaluate the entire arrival experience.
Right, like can I easily see the stalls from the street? Is there room to maneuver a larger vehicle or a trailer without totally stressing out?
Yeah, is it well lit? Is it safe at night?
Exactly. Is there an easy path to a clean restroom? It's product design, civil engineering, and hospitality all just colliding on a patch of asphalt.
And the consumer data strongly backs this up. Bart Saunders highlighted the latest JD Power study on public charging.
Oh, what did that say?
So fast charging satisfaction is up 27 points year over year, which is a substantial leap. But the really fascinating detail is that 3 different networks now actually outrank Tesla superchargers in overall satisfaction.
Wait, really? 3 of them?
Yeah.
That is a seismic shift in consumer perception compared to even 2 years ago.
It is, and a lot of that satisfaction correlates directly to location amenities rather than just pure uptime. The study showed that sites located at hotels rank the highest for satisfaction, followed by convenience stores and restaurants.
Makes sense.
And dealerships, which often have chargers locked behind gates or completely blocked by inventory, they rank the lowest. So what surrounds the charger is truly becoming the primary differentiator.
By the way, if you are enjoying this deep dive into the underlying mechanics of the mobility transition, make sure you hit subscribe on the feed so you don't miss future editions. We are tracking these structural shifts constantly.
So while the ideal customer experience focuses on amenities, operators also have to confront the gritty physical vulnerabilities of these sites.
Yeah, we have to talk about the copper theft epidemic. People are literally cutting the thick, heavy cables off public chargers just to sell the copper as scrap, completely bricking the station.
It's awful.
Tor Solar Fred Valenza raised a really provocative proposal to combat this. He suggested a bring your own cable, or BYOC, standard for level 2 and 3 chargers. You basically keep the heavy, expensive cable in your vehicle, plug it into the station, and then take it with you when you leave.
Which is an interesting idea because it removes the target for thieves entirely, pushing the liability of the cable onto the owner.
It does, but the physics of fast charging make that almost impossible to scale for consumers.
Yeah.
I mean, a liquid-cooled DC fast charging cable capable of pushing 400 amps is essentially a high-pressure fire hose full of glycol.
Okay.
It's thick, it's rigid, especially in cold weather, and incredibly heavy. Asking a consumer to wrestle a dirty fire hose out of their trunk in the rain directly contradicts the premium retail experience we were just talking about.
It really does. But the fact that the industry is even debating consumer-carried liquid-cooled cables shows how severe the vandalism issue has become.
Yeah.
It also highlights why we need rigorous, standardized safety protocols. Graham Warnell shared a really sobering reality check after finding a badly burned 3-pin plug socket in a multi-story car park.
Oh, wow.
Yeah, EV owners, desperate for a charge, were plugging standard cables into these charred domestic sockets that were just never rated for continuous high-amperage draw.
That is a catastrophic fire hazard waiting to happen.
Exactly. Which is why the industry is moving aggressively towards smarter, heavily regulated standards on the back end. Yulia Zabudska shared insights from the Mercury Consortium, which just certified its first 3 devices. And they are setting really strict technical requirements for how chargers must behave when interacting with the wider grid.
So they're essentially writing the software rulebook for grid compliance.
Exactly that. For instance, they mandated sub-3-second response times. So when the grid experiences a frequency drop and sends a signal to ramp down power to avoid a localized blackout, the charger has to respond almost instantly.
Oh, that's smart.
Yeah. They also instituted an anti-stranding rule. So if a manufacturer's cloud connection goes offline for 7 days, say due to a software company going bankrupt, the charger has to allow a local override. This ensures the site owner can switch network providers without their hardware turning into expensive paperweights.
That resilience is crucial. So passenger car networks are refining the retail experience and locking down software standards. But commercial fleets are playing a completely different game, one that basically solves for logistics, math, and raw industrial power.
It is an entirely different order of magnitude. And the strange thing is, from a macroeconomic planning perspective, grid operators are largely flying blind on where this commercial power is actually going.
Yeah.
Chris Jackson made a brilliant observation about the data gap in European truck charging.
The disparity between public monitoring and private realities?
Precisely. Europe rigorously tracks its 2,405 public truck charging sockets. I mean, they are mapped down to the individual plug on government dashboards.
Sure.
But the system completely fails to track private depot chargers. And the ICCT expects that 70 to 80% of fleet energy will actually be consumed behind the fence at private logistics hubs. So grid planners and policymakers are modeling the future of the grid based on the smallest fraction of the actual energy demand.
That blind spot is terrifying because we aren't talking about 50-kilowatt passenger chargers here. Harlow Ribeiro highlighted MAN Truck and Bus recently hitting 750 kilowatts on the new megawatt charging system, or MCS.
That takes a heavy-duty commercial truck from 20% to 80% battery capacity in under 30 minutes, which is wild.
Pushing 750 kilowatts requires astonishing thermal management. You can't just push that much current without melting components. I mean, it requires intense liquid cooling in both the dispenser and throughout the truck's battery pack.
Right.
But hitting that 30-minute window is the holy grail because it perfectly aligned with the driver's mandated rest break. It means the charging process no longer penalizes the freight schedule.
And the physical architecture of the trucks is evolving just as fast to support this. Tobias Engvall noted that Volvo's upgraded FH Aero Electric is adding 60% of its total range in just 50 minutes on megawatt charging.
Oh, wow.
Yeah, and more importantly, they completely redesigned the axle. By moving the electric motors directly onto the rear axle, they freed up substantial chassis space, which allowed them to package the batteries more efficiently and unlock 2 extra tons of payload capacity.
That is massive for a fleet operator.
Huge. They are systematically removing the traditional compromises of electric freight.
And this transition isn't waiting for the next decade either. The deployment speed is accelerating right now. Chris Welch just took a megawatt charging hub live at his depot in Cambridge after a grueling 18-month build process involving, these complex grid upgrades. And Jan-Niklas Ellerich announced a public truck charging park opening in Germany. These immense industrial power hubs are switching on today.
But to push megawatt charging into a vehicle without the cells physically degrading or just catching fire, the underlying battery chemistry has to evolve. And as that chemistry gets more advanced, it is fundamentally reshaping global supply chains.
Let's look at the market concentration happening right now. Ashley Zumwalt Forbes laid out a stark warning about CATL. They now hold roughly 40% of the global EV battery market. But their strategy has expanded far beyond just mobility. They are pivoting heavily into building energy storage systems designed for AI data centers and grid-scale backup.
She made a very apt comparison, likening CATL to TSMC in the semiconductor space.
It's the perfect analogy. I mean, TSMC manufactures the world's most advanced chips, creating a bottleneck everyone relies on.
Yeah.
And CATL is doing the exact same thing with batteries. through this aggressive vertical integration. They don't just build the cell, they're involved in refining the raw lithium, manufacturing the pack, and writing the battery management software.
Right.
So Western automakers are increasingly just buying a highly optimized black box. It creates this dual-pronged dependency where both our mobility infrastructure and our AI computing infrastructure rely on a single manufacturing choke point.
While the geopolitical implications of that are definitely complex, the technology they and others are producing is undeniably robust. And we have enough empirical data now to dispel the lingering myth about how these batteries actually perform in the real world over time.
Yeah, there is this persistent, really outdated assumption that consumers will have to replace a $15,000 battery after 5 years. But Raul Arredondo shared data from roughly 10,000 real-world battery tests, and it showed that Korean models, specifically the KIA e-Niro, are retaining over 97% of their original capacity after 62,000 miles.
Which is incredible. Retaining 97% after that kind of mileage proves that battery degradation isn't a cliff you fall off. It is an incredibly slow, manageable slope.
Right.
The internal software holds a hidden charge buffer, and the thermal management systems condition the battery before fast charging. The engineering is doing exactly what it was designed to do to protect the cells.
I mean, I have to push back on what we even call these machines at this point.
What do you mean?
Well, if the battery degrades that slowly, and the electric motors have a fraction of the moving parts of a combustion engine, the lifespan of the powertrain vastly outpaces the lifespan of the car's interior.
Oh, totally.
So is an EV actually just a highly durable rolling energy storage system that happens to transport people as a secondary function?
Economically, you might be right. The residual value of a 10-year-old vehicle might eventually be tied closer to its remaining battery capacity for grid storage than its actual mileage.
Yeah.
And the innovation curve on these rolling batteries is currently outpacing the grid's ability to support them.
Which brings us to the charging speeds. Martin Salomon highlighted Geely's new 900-volt LFP battery. Now, LFP stands for lithium iron phosphate, a chemistry that is famously durable and doesn't use volatile cobalt, though historically it was just too heavy for high-performance cars.
Right.
But Geely managed to charge this new LFP pack from 10% to 70% in roughly 4 minutes.
The physics behind that 4-minute charge basically come down to the 900-volt architecture.
Right, because of Ohm's law.
Exactly.
Power equals voltage times current. So if you double the voltage to 900 volts, you can push the same amount of total wattage while basically cutting the current in half.
And current is what creates heat in the wires in the cells.
Exactly. So less heat means you can push power in faster without degrading the battery.
The catch is that outside of highly specific test environments, the global charging network just isn't ready for it.
No.
The technology inside the car is here, but the physical infrastructure to feed it power that fast simply doesn't exist at scale yet.
Because these batteries are so vast, so durable, and capable of moving energy so quickly, they are poised to become the most important distributed asset for the global energy grid itself.
Yeah, this is where vehicle-to-grid, or V2G, transitions from just a theoretical concept into a physical reality.
Okay.
Sleep Kerchod shared an incredible analysis of a program in Denmark that enrolled 10,000 electric vehicles into a V2G network.
And the combined battery capacity of just those 10,000 parked vehicles equals 400 megawatt hours.
That's massive.
That holds more capacity than any single purpose-built grid-scale battery installation in the entire country.
And the grid operator didn't have to spend a dime of capital to build those batteries. The consumers bought them to commute. And while they're parked 95% of the day, the grid operator can pull tiny amounts of power from them to stabilize the network, paying the owners for the privilege.
It totally transforms a depreciating asset into a revenue-generating grid appliance. And it is hitting the mainstream faster than most realize. Matthew Bell noted that Volkswagen is unlocking bidirectional charging capabilities on more of their 2026 models.
Yeah.
And they aren't doing it with a massive hardware recall. They're unlocking it via a free over-the-air software update.
Suddenly, tens of thousands of vehicles are capable of powering a home or feeding the grid overnight. The implications for grid architecture are profound. Kurt Johnson argues that our current centralized grid model is inherently fragile. I mean, we see recurrent transformer shortages and deep vulnerability to extreme weather events, all the time.
Right. He believes we are being pushed toward a decentralized microgrid architecture. So neighborhoods, corporate campuses, or even single homes that can disconnect and operate independently when the main grid fails.
Exactly.
And the cornerstone of that resilient architecture isn't a noisy diesel generator. It is the bidirectional battery sitting silently in the driveway.
Ziveltonder takes that concept even further, injecting an autonomous edge.
Oh, this was wild.
Yeah. Imagine a scenario where the local grid is under extreme strain in a specific neighborhood during a heat wave. Autonomous EVs, acting as mobile batteries, could literally reposition themselves. They'd drive to where grid support is needed most, plug in, and balance the load without human intervention.
It completely flips our assumption that an EV only provides grid services where its owner happens to park it. It turns the entire vehicle fleet into a dynamic, dispatchable energy reserve.
It really forces us to entirely rethink the relationship between mobility and energy infrastructure.
Let's synthesize all of this. For years, the mainstream narrative, the anxiety everyone harbored, was asking the same question. Can the aging power grid handle millions of electric vehicles?
Right, we've all heard that.
But looking at the unprecedented decentralized storage capacity of these bidirectional batteries, looking at how they can stabilize entire regions with zero capital cost to the utility, the real question going forward might actually be, can the aging grid survive without them?
That is the paradigm shift defining the next decade.
If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on commercial fleet insights, autonomous mobility markets, and software-defined and AI-defined vehicles.
Thank you all for joining us on this deep dive. We appreciate your time.
Thanks for listening, and don't forget to subscribe. We'll catch you on the next deep dive.